sana.
Dalam ni mana nampak? Kau dah tengah betul-betul kawan ni. Foundation ke? Okay.
Petang lah, petang. Petang makeup dah tak ada. Belum tekan. Dah. Ha. Mia, pedas aku punya ni. Foundation kau pedas. Dia macam bisa.
Satu minit. Mic on tak, mic?
On ke bawah Saya dah tak nampak lah. On. Testing ada. Testing 1, 2, 3. Good morning. Buka. Ada. On. Kita tengok. Testing 1, 2, 3. Ke bawah sikit. Cubaan suara 1, 2, 3. Cubaan. Bawah sikit.
Dengar, keluar tak suaranya?
Good morning. Cubaan suara. Testing. Assalamualaikum warahmatullahi wabarakatuh and a very good morning, ladies and gentlemen. Day 2 of the 7th International Conference on Soft Computing and Data Mining SCDM 2026, University Tun Hussein Malaysia, is about to start. Just a little housekeeping before we get started. Please be reminded to turn on your cameras and mute your microphone to keep the quality of the sound functional during the event. If you have any questions or queries, especially during the keynote speaker presentations, please type them into the chat box and I will bring them up during the presentation if necessary. Our virtual SCDM Conference 2026 will begin shortly. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Dr. Muhammad Firdaus Abdul Aziz, shall be your host for the day. Allow me to extend our warmest greetings to our eminent speakers and guests, the Honorable Professor Technologist Dr. Mas Fauzi bin Muhammad Ali, Vice Chancellor of University Tun Hussein Malaysia, the Honorable Associate Professor Dr. Nurhalina binti Senan, Chairman of the 7th International Conference on Soft Computing and Data Mining SCDM 2026, Professor Technologist Dr. Mak Farhan bin Mak Fuzi, Dean of Faculty of Computer Science and Information Technology, University Tun Hussein Malaysia, SCDM UTHM, our respected third keynote speaker, Professor Dr. Nazri bin Muhammad Nawi, Professor, Doctorates, Academicians, Researchers, ladies and gentlemen. A very good morning, welcome back, and thank you all for joining the second day of our virtual 7th International Conference on Soft Computing and Data Mining, SCDM 2026, University Tun Hussein on Malaysia. We would like to give our highest gratitude to Nice Insight Cinderberhad for sponsoring our conference for today. Distinguished guests, ladies and gentlemen, I would like to share or recall what happened on the first day of our conference yesterday. We benefit from the presentation of two esteemed keynote speakers. The first one is Dr. Muhammad Khairul Ikhwan Ahmad, Lead Robotics and Smart City Unit from Cyber Solution Technology, Cinderberhad, Dr. Fazli Wahid from University of Derby, United Kingdom, and in the afternoon, two parallel sessions were successfully held, involving presentation by nearly 14 presenters. And today, we will have a session with our third keynote speaker, followed by the next parallel sessions. And at 2:30 p.m., we will conclude our event with a closing ceremony and announcement of the Best Paper Award for SCDM 2026. And all are invited to join the session in this afternoon. Distinguished guests, ladies and gentlemen, let us start our conference with the recitation of Doa by Mr. Muhammad Bakri bin Osman from SKTM.
Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil mursalin. Wa ala alihi wa sahbihi ajma'in. Allahumma innaka khalqul azim. Innaka sami'un alim. Innaka ghafurur rahim. Innaka rabbul arshil azim. Innaka al-barul jawadul karim. Allahumma ya karim. Ya rahim. In conjunction with the 7th International Conference on Soft Computing and Data Mining 2026 program, which will be commemorated by the Honorable Professor T.S. Dr. Mas Fauzi Muhammad Ali, Vice Chancellor, University Tun Hussein on Malaysia. Today, we ask for your mercy and guidance. Bestow upon us your blessings and sanction on this harmonious union of us. Verily, only towards you that we feel grateful, and only from you that we seek favor. May today's ceremony be blessed and smooth sailing. We ask for your grace today in conjunction with the ceremony. Provide us with prosperity and happiness. Open our hearts and minds so that we can acquire knowledge and insights for the sake of our religion, people, and nation. We seek your blessings for the success of this program, as today we are united for the sake of you, Ya Allah. We unite to acquire knowledge, to exchange opinions, to communicate and to support each other towards improving and enhancing our performance. Provide us with strength, Ya Allah, so that we are able to execute goodness. We seek for protection from sins and wrongdoings. Ya Allah, grant us the richness of knowledge and shower us with humbleness and honor us with portionless and bequest us with health. Rabbana alayka tawakkalna wa ilayka anabna wa ilaykal masir. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adhaban nar. Wa sallallahu ala sayyidina Muhammadin wa ala alihi wa sahbihi ajma'in. Walhamdulillahi rabbil alamin.
Amin, amin, ya Rabbal Alamin. Thank you, Mr. Muhammad Fakir bin Osman, for the dua recitations. Distinguished guests, ladies and gentlemen, proceeding with today's event, it is a great honor for our conference to welcome the third keynote speaker, the Honorable Professor Dr. Haji Nazri bin Watnawi, our steering committee member from Faculty of Computer Science and Information Technology, to deliver his speech. Before that, let me share a brief information about our speaker. Distinguished guests, ladies and gentlemen, Professor Dr. Nazri bin Watnawi is a distinguished Malaysian academic and researcher specializing in Artificial Intelligence and Soft Computing at University Tun Hussein of Malaysia. He holds a Bachelor of Science in 1997 and a Master of Science in 2001 in Computer Science, and followed by a PhD in Data Mining from Swansea University, United Kingdom, which he completed in 2007. And since joining UTHM in 2001, Professor Nazri has demonstrated extensive leaderships, serving as the Deputy Dean from 2008 till 2013. Then, and as a Dean for the Faculty of Computer Science and Information Technology 2013 till 2018, and head of the Soft Computing and Data Mining Center, or SMC, of SCDM UTHM from 2018 till 2021. And his recent administrative contributions include directing the Information Technology Center, or PTM UTHM, from 2021 to 2025. And professionally, Professor Nazri is a recognized authority on artificial neural network, or ANN, and focusing on the optimization of backpropagations algorithm and the development of meta-heuristic techniques such as cuckoo search, BAT, artificial bee colony algorithm, and his prolific research output includes over 100 referred papers covering topics from deep learning and image classification to data mining applications in manufacturing and medical diagnosis. And beyond his publication, he has significantly impacted the academic community as the program chair for the Soft Computing and Data Mining International Conference, SCDM series, and as an editor for prestigious Springer publication. His research excellence has been honored with multiple awards, including the Best Paper Award at the 2015 International Conference on Man-Machine System and several UTHM honors for high citation impact and publication volume. And in 2026, he remains a key figure in the field and recently co-authoring pioneering work on intelligenomics-based frameworks and serving as a principal researcher at the Artificial Intelligence and Data Mining Center, AIMC. And his career reflects a steadfast commitment to technological innovations and the advancement of Malaysia digital and academic landscape through high impact research and institutional leaderships. And now, without further ado, please join me to welcome Professor Dr. Nazri Muadnawi to deliver his speech entitled SCDM 2026 and Beyond, Harmonizing Human Intuitions with Soft Computing for Sustainable Innovation. Please welcome Professor.
also to our two keynote speakers yesterday's. Dr. Carol is one that presented very well in terms of artificial intelligence that been used in smart city. I think a lot of information that was delivered by Dr. Ikhwan. And also thank you to Dr. Fazli from Derby. You share a lot in terms of the technical of medical imaging. So I think both of you, hopefully that we can collaborate more after this and then make this conference more reputable conference. All right, let me introduce myself. My name is Nazri bin Muhammad Nawi. I'm the principal researcher for Artificial Intelligence Data Mining Center in FSKTM. So without further ado, let me share my slide before I start my discussion. Right, so hopefully that everybody can see my slides. So as been introduced by the chairperson, I'm going to talk about harmonizing human intuition with soft computing for sustainable innovation. So I think that everybody knows, all of you that presented your paper in this conference, everybody is using whatever method in soft computing, right? So in order to solve your problems. But the idea of this talk is to leverage the others capabilities of human cognition, right? So because some of this we only depend solely on one capable. I mean, once you develop any model, then you develop solely on the results or the decision that making by those model without second thought. So sometimes it can be used, but sometimes it's going to cause dangerous decision, particularly that involve with a critical decision making, right? So this is the thing that I'm going to talk about. We're going to try to how that we can harmonize these two capabilities together so that we can solve the problem, and also particularly how that we can help the community instead of just focus on the capable of one model and no impact on the society. Right, so so this is some of my layout of my presentation. So I divided into 9 sections of my talk. So basically, in section 1, I'm going to talk about what are the blur boundaries that divided these two capabilities, right? So that we can aware that where is the boundary that we can cope together, so that we can leverage the usage of these capabilities. And also I'm going to talk about the silo perspective, right? Because we have the boundaries, and then all the capabilities is doing their own job, silo, right? So actually this silo need to be converged so that we can leverage, as I said previously, we can leverage the capabilities of both. And also I'm going to talk about more towards on the collaboration, right? Not replacement each others, right? Some people thought that by using AI, we're going to replace human workers or human thoughts. So basically, it's not like that. So we try to look on the other side in terms of the collaboration, what we can collaborate instead of talking about replacement. On second section, I'm going to talk about the core objective the about this slide regarding the balance and the harmony. All right, and then I'm going to talk about what will be the machine core that everybody knows. What are the capabilities of the machine itself, and then we look at the human core, the human cognitive. What are they, right? And also, I'm going to give one of the samples about one case studies uh, in talking about these two capabilities. In section 3, I'm going to talk about the navigating 2026 landscape, right? How that we can synergy these two what do you call it, these two capabilities, and followed by another case studies. In section 4, I'm going to talk about I think probably the most important one, the soft computing timeline, because most of us are coming from soft computing researchers, right? So we need to know what are the timelines, starting in the middle, current, and then what will be the head in forward. So where this soft computing will be in our in our side, right? And also we're going to talk about the brain of modern technology, and then we're going to talk about the computing paradigm shift. So how that we're going to we compare between hard computing and soft computing. Where does this divided into? And then I will discuss a little bit about milestone one. We have milestone one, milestone two, milestone three. So this milestone I'm going to talk about a little bit, not very technical one, on backpropagation algorithm itself, and how does this backpropagation shift to deep learning, right? And followed by the mathematics of weight adjustment. I think everybody knows the power of the backpropagation itself coming from the weight adjustment. So how does this weight adjustment happen that make the what you call it artificial neural network very powerful? And then deep learning in medical imaging, one of the examples, and then followed by another milestone. I'm going to touch a little bit about meta heuristics and natural intelligence, and followed by a few examples. I just pick up randomly, talk about cuckoo search that been used in urban logistics, and also how that bad algorithm been used for dynamic update. So in section 7, for the milestone 3, I'm going to talk about the 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 common perspective that people that coming from not from the soft computing or the data mining, everybody talking about the result that you get it from all the machine learning actually is a black box perspective. So how that we overcome this kind of perspective, right? So that's why another milestone coming, they call it the push of explainable AI. And also, what will be the missing link in this in terms of sustainability? And in section 8, I'm going to talk about the paradigm shift, where from here we're going to show how that this all these all AI models and AI techniques can be worked together, and then we put it as a tools, or maybe as a partners that helping many applications nowadays, right? Then I will describe a little bit about some of the trending application that using AI. And in the last slide, I'm going to talk about what is needed in terms of for the next generation once they're going to come out to be expert in data mining. So what sort of training that are needed for them, and also the vision for 2030. So how that we're going to look this soft computing in next 2030. So they call it as an invisible seamless soft computing. So what is it? So that one I will elaborate in my slide next, and followed by the last one, conclusion. Sorry for that. All right. So let's start my discussion regarding blurry boundaries. So the convergence of two worlds. So as I mentioned in early slide, so we have two different perspectives. Talking about the machine learning capabilities, and the other one is the human cognitive capabilities. So basically, everybody knows we have that kind of capabilities, but when we put it together on table, we still couldn't find the real boundaries of these two capabilities, right? So that's why I say that it's a blurry boundaries. Everybody knows, oh, this method is very good solving this problem. So does we ever notice about sometimes at urgent cases, sometimes we cannot blindly depend on one certain result from machine learning techniques, particularly in situation that really critical that need human touch for another decision, for critical decision, right? So that's why I think this boundary is still not very clear. Then that's the thing that I'm going to try to discuss further in my next slide, right? Right. So in history crossroads, so why did these blurry boundaries happen? So basically, because as I mentioned just now, it separates human cognition from the machine intelligence, right? So if you're talking about nowadays a new era of advanced technology, so basically we need to look beyond the limits of both humans and AI, right? Not solely or blindly depend on one methods and got the result and finish, right? So as you can see, if you look at the history assumption, for decades everybody knows once machine learning was introduced, you force the machine learning to confine to crush numbers in silos. Means that you do it and then you settle it as long as giving the data that enough, and then you will get the result, right? However, if you talk about solely responsible for high level decision making, that is how that we implemented today's, right? So you let the machine do the job, and last sometimes we refer to the experts to come out with a high level decision, or sometimes we don't ever care about that, just leave it to the result and blindly uh, trust the result, right? So in modern reality, so these two worlds actually are rapidly converging, right? So the competition and iteration are no longer separate. We should look at these two perspective not in separate way, right? So we have to to make sure that it is look as a interdependent, right? We need each other in order to come out with a good result, and also to make sure that the it's going to be bring a big impact to the community. So that's why I say that it's about collaboration. It is not about a replacement, right? So in order to make sure that these capabilities being used properly, we need to collaborate together, right? We don't say that let the machine do their job and let we do our job, right? So we need to look at the interlocking system. So we have to connect the strengths of both rather than replacing each other. Why? Because nowadays you're talking about multi-dimensional data set, right? So you're not talking about two-dimensional, three-dimensional. You are talking about multi-dimensional data set, a problem, multi-dimensional problem, right? And you are talking about a real problems that Neither each of these can solve immediately, right? So another thing is that augmented intelligence. So it can enhance the human capacity. I mean, by collaborate together, you can enhance the human capacity for judgment with the help of algorithm that you process. So let us look at the core objective of this talk. We're going to talk about the balance and harmony, right? So the balance and harmony. So basically, the goal is to establish the perfect equilibrium between this massive raw data processing with of the machine with the human thoughts, because we know that it is no doubt algorithms is very powerful. It can identify the statistical landscape very well, and human only provide the qualitative oversight, and the last will be the moral finality. But sometimes, as I said previously, we don't care about that as long as we got results, and then we leave this second perspective, particularly about human perspective. So let us look at what will be the mission core in finding the patterns at scale. So why that this machine learning is very good. I think all of you have done a very good research, and you know what it is all about, because machine learning is good in doing synthesis, right? It's good in quantitative synthesis of pattern. You give them across billions of distinct of data, and also at simultaneously they can do it. They can synthesize the data, right? You give one examples, the capabilities of ChatGPT or Gemini. Just give them all the charts and let them do the process, and they will come out with the solution. And the other thing is about machine is that they are good in reasoning. Uh, in the early stage, the reasoning means that they combine the capabilities of neural networks with fuzzy and also the probabilistic reasoning, particularly for complex data. And the last, the capabilities of machine is that they are good in optimizing, right? You know that in optimization, basically they are strictly bound with a mathematical optimization, right? Why? Because they are looking for a very precise and accurate result. So this is the machine core that everybody knows. So what about the human core? So the human core, so basically this is the thing that sometimes we don't realize. I mean, because human, they possess a life experience, right? We have empathy. We have ethical constraints that, of course, algorithm don't have. And also, sometimes human can apply moral reasoning, right? Particularly for a critical decision. And the most important thing is that everybody's always keep on asking. So, what is good? So what is the intuition that you're talking about human? So basically, the last is about common sense, right? So that is the most important intuition that have in human, because once we have this common sense, then of course the once we go for the critical decision, then we'll look at the ethical penalty. So we will base on what will be the ethics or not ethics in supporting the result that been processed by the machine, right? This is I gave one very simple examples. If a pandemic happened in 2020 when what do you call it, COVID around the world. So one cases, I mean, just we look at one hospital. All right, they have a few ventilator, that need to be provided to many patients. So basically, if you ask doctors, so doctors say that we have to look back what will be the history data of the patients before we provide the ventilator. If you're talking about one patient, then it should be okay. But if you're talking about 100 patients, then the doctors definitely cannot process all those information. So they leave it to AI to do the processing based on the data that provided. So as we can expect it, so basically AI is good in doing those risk assessment process. So they come out with a very quick result. So cut off the time for the doctors. But however, basically based on the data that provided, the AI will definitely will based on the metrics of basic things. So basically, you're talking about human with 30 years old have a chances of living rather than a patient with 75 years old. Right. So this is the thing. Basically, the critical decision that made by machine, and sometimes, if without doctors inside, so maybe the decision is wrong, right? Because you're talking about life. So that's why if you ask doctor, basically once everything been processed, so doctor will look back. Okay, so this is the result that suggested by the machine AI. Then they will look back. Okay, so yeah, the machine suggests for 30 years old, but based on the doctor's knowledge with the patient, they know that this guy not have a very what do you call it, high spirits to survive, right? Or maybe there's no support from their family at all. On the other side, for patient with 70 years old, very good support from families, and very struggle to survive. So based on that common sense, so basically, then the doctor will decide another way around. But using AI to what do you call it, to simplify their job in classify all those patient needed. Right. This is the thing that we are talking about. So if you let the machine to do their job, basically they will just based on the metrics given, and that the result will be given, and straight away if you blindly follow the result, then what I call it, the catastrophic, you will cause human life, right? So this is just one example. Let's look at we look at the navigating 2026 landscape. All right. In 2026, I think nowadays we are talking a lot in terms of the combination of generative AI and meta heuristic, right? They now start to combine these meta heuristics with generative AI, and some say that it's going to reach the unprecedented maturity. And the best thing is that the usage of this combination is being used not only for medical or simple purpose, sometimes being used for commercial usage, right? And even for the UN Sustainable Development Goals, they use this combination very well, right? So how the synergies works? So basically, generative AI, you know that it can imagine all the possibilities, right, by using generative AI. Why? Because nowadays the availability of the data itself is massive, right? Because they can synthesize decades of data to simulate thousands of hypothetical scenarios, and also to come out with novel designs based on that massive data, right? Then people start also to use what do you call it, meta heuristic. Why? Because basically, uh, meta heuristic been used to find the path, because nature inspired algorithm basically they try to look through in the space search space to find out the best the most efficient route for them to survive, right? And if you combine these two, generative AI and meta heuristic, then basically what this is what they call it as a soft computing, right? Because they can balance the creative exploration with a rigorous optimization. So I gave you another example. Example I think is quite common in African side. They use this precision agriculture. In 2026, quite recent. So generative AI leverage the climate data and also satellite imagery and soil microbiology to simulate thousands of crop rotation scenarios. So they create many scenarios based on this collected data, right? So what they are looking is that they want generative AI to reimagine farming by predicting outcomes before a single seed's been planted. So before they start planted, they want to look at the what will be the scenario, the optimal scenario if we start to do the planting. So this is where they use PSO, right? Because everybody knows PSO is like a swarm of bees. They living through looking for what do you call it food. So in generative AI, because generative AI they create many scenarios, right? But within the scenarios, basically there will be the most optimal one. So then PSO been used in order to find the single flower. I mean the best point, the best scenarios within others that going to maximize the yield, and at the same time they try to minimize the resource that been used. Right. So basically by using this combination, the results they improve the predictive water management, they improve the automated crop rotation alerts, and also they improve the precision nutrient delivery. And the best thing is that it's maximize the crop yield and nutrition. And at the same time, they minimize the usage of groundwater and pesticides. So this you can see how the combination really impact to the society. Another case study basically is about the decarbonizing global logistic, right? So you're talking about many ships that cross the world. So they look at a novel aerodynamic engineering, right? Again, it is in 2026, quite recent, because they look at the shipping. They produce a massive percentage of global emissions. So they need to overcome this by using generative AI. They create and design hull shape ship that never been designed before, like the one in the pictures you can see. And then by mimicking, this one is done by mimicking organic aerodynamic structures, right? Again, they use a nature inspired to create this design. And then ant colony being used as algorithm that map the global shipping routes, like the way that ants finding their job, right? So they leave their they call it as a digital pheromones, right, on the most efficient path, and then the algorithm help the ship to serve the natural ocean currents and wind patterns smoothly and efficiently. So what are the result of this? By using this combination, it allow the global fleet to slash the usage of fuel consumption and carbon emission by 30%, right? And the ship dynamically adapt to port congestion and real-time current changes. So easy for them to maneuver and finding the shortest and cleanest path. At the same time, try to reduce the usage of oil emission. So again, you're talking about something that bring impactful to the society by using this combination. All right. Let me table you or give you an overview about soft computing evolution. I think everybody knows but the most important thing, once you choose to do your research on one particular method, you should know how that method evolved, starting from the creation, at the middle, where does it goes, how it's combined, and how does towards the end, how that it's going to be, right? So this is very important so that you will know you are in the what do you call it, the right position of doing this research. Are you going to talk about there is this research is still significant, relevant, or not relevant, right? This has happened to me, right? As you can see, I will talk later once we go to the phase 4. Okay, in phase 1, basically there's the foundation of soft computing, where we know that the starting point of where they found artificial neural networks, that is found by Warren McClough, right? I think he's a mathematician, he's not a biologist. And then at that time also, Alan Turing start to propose the Alan Turing test. Huh? And then in phase 2, uh, where the tools was introduced, we call it tools. Within this period, a professor called known as Lopizadeh start to introduce fuzzy logic, right? And at the same time, some researchers doing the same thing and then propose a genetic algorithm. And then in phase 3, in 1980 to 1990s, the synergy start to happen. I mean, they start to combine each other's, right? Fuzzy with neural networks and genetic algorithm. They start to combine this algorithm. And in phase 4, starting from 2000 to 2019, right? That's where I think at that time the power of computing GPU start being introduced, right? And once GPU was introduced, then they start to leverage the power of artificial neural network to go for deep learning. So I pause here in phase 4 just to share with you all my experience because I did my PhD starting from 2003, right, and finish at 2007. So at that time, I think I don't know how that I choose to go to do my research on artificial neural networks. I think maybe because my supervisor at that time he's doing a research on manufacturing, and he wants me to improve some of the algorithm for that being used in manufacturing. So it come out that I choose neural networks in 2003. So you can imagine during my readings at that time the usage, or I mean the research on neural networks, I think all over the world. I think it's very easy to get papers on neural networks on any applications, right? So I thought at first I thought that okay, so it's good for me to have this research with many of reference. But suddenly towards my second year, I think second year, so I heard some of the researchers during my presentation in my some of the conference, they start to chatting saying that artificial neural network is going to be saturated anymore, right? So at that time it's 2004, 2005. So you can imagine you are still doing your research on that, and suddenly all many of the people researchers start to talk about the things that you are doing is going to be saturated. So how that you're going to feel that in that way. So basically, if you are not strong enough, so basically you're going to demotivated. But lucky for me, because I still continue my research on artificial neural network, and then start looking at any possible way in order to improve neural network. I think if let's say that most of you know about neural network, there's not a lot of parameters that you can adjust it. You talk about neural network, you will talk about basically the momentum. You adjust the learning rate, you adjust the way that you do the processing, whether you go by batch or you go by online. You change your attribution function, whether you're going to use a sigmoid or you're going to a tangent. So that's it. I mean, that's the some of the parameters that you can control. So you can imagine. So it's very difficult at that time to find out what will be the best improvement that you can do along that side. So lucky for me, I drill down many cases until I find out, okay, in attribution function, you can drill more to look at the stepness of the attribution function. So you can control the stepness of the attribution function by introducing another parameters, a parameter they call it as gain parameters. So that was my contribution of PhD research. If you look back, you put it on white paper, it's just a small dots solution, but it's bring a big impact to my research. So that's why, Alhamdulillah, 27 I finished my PhD. Lucky for me, I thought that, oh, lucky for me because I passed my PhDs and I get out from the, what you call it, the saturated area of research. But suddenly, I think if you still remember in 2012, right, there's where the deep learning started to bloom, right? Because at the time the GPU is getting powerful, and then they start to elaborate on research on artificial neural network, and then what do you call it, deep learning was introduced. So you can see that at the same time you thought that the research that you are doing is going to be saturated. I mean, then suddenly it's boom, and until now the research has keep going on based on deep learning, and based on, you know, that the deep learning the deep learning is solely based on the architecture of artificial neural network. So my advice is that once you come out with this kind of situation, people thought that it's going to be saturated, just keep on moving, right? So try to find out as many possible as you can to improve the things that you can do in your research, right? All right, so that's some sharing that I can share about you with you about my PhD. So let's look at the brain of modern technology, right? So basically, people say that hardware acts the body and the soft computing serve as the brain, right? Why that people say that soft computing as a brain? Because you know that once you use soft computing, you are talking about you can derive the results on imprecision and uncertainty. As compared to the previous optimization technique, you are talking about very rigid and very precise numbers. But using soft computing, you can calculate something that imprecise and uncertainty, right? And you can operate on what do you call it, partial truth, and also you can adapt much like a living organism. So that's the thing that why they start to introduce soft computing, right? Because unlike hard computing, soft computing try to mirror the human-like intuition and also the natural optimization strategies. Okay, this is just a comparison. I think, as I mentioned just now, what will be the difference between hard computing and soft computing? So basically, if you talk about hard computing, you are talking about exact models, right? And you're talking about the rigid logic. Only you're talking about binary outcomes, whether it is true or false, or it is 1 or 0, and it is absolute precision, right? Rather than soft computing, it is designed for imposition. It can adapt to a new information, and it can manage the real world complexity through learning. So that is the best thing about soft computing. The powerful is about soft computing, they can adapt from the learning, right? So let me touch a little bit about the fundamentals of before we go to the deep learning. So as I mentioned, the base of the deep learning actually coming from the artificial neural network. And in the neural networks, what are the algorithms that been used? Basically, they just use a simple, they call it as backpropagation algorithm. Right? So this is the thing, backpropagation algorithm. Uh, People always asking, as I mentioned early, what is the powerful of the backpropagation itself? So the powerful about the backpropagation is on its weights. Why its weights? Because using that weights, it's going to adapt, it's going to modify based on learning and then come out with a new result, right? So that's why backpropagation was the breakthrough before we start to use deep learning. So how to understand this backpropagation is very simple. Just you take one example, students, right? They go for a test, right? And then it answer the test, and the teacher came, oh, your answer is wrong. You should do here and that in order to get the new result, the new better result. So the students go home and start to retrain, doing more training based on what been suggested by the teachers, and then coming back and then sit again and check again, and then the process will continue until the result is correct. So that's how the simple way to show how that propagation learn from learning process, right? Because it's learned from the training data, and then it match the target with the calculated results. If the difference is big, then that difference will be propagate back to the weights, and the weights adjust that weights, and then forward again, and then match again the target with the target until the difference come out to zero, or maybe very less to zero, means that you are very close to the answers. So that is how backpropagation works, right? It's very simple. And then how does this help uh, deep learning to expand? So basically, deep learning is using the same architecture of artificial neural network. They have three layers. You have input, you have output, and you have hidden layers. But in deep learning, they put it extra layers inside the hidden layers. Sometimes thousands of layers inside the hidden layers. That's that make they call it the architectures expandable and more powerful, and that's they call it as a deep learning, right? So I think our second keynote speakers did describe very technical discussion on medical imaging. I don't want to touch about that, but basically by using this deep learning. So how does these layers working together, right? Basically in early in the input layers, so they just identify basic edge and shadows, right? In the middle one, so they start to recognize a complex shapes and textures. And in the final layers, in the upper layers, then they start to synthesize data to detect whether it is a malignant tumors or not, right? So seems like it's very simple, but the way the calculation is not as easy as we thought. And of course, because you are talking about too many layers, then you are talking about too many weights that need to be adjusted. If your computers is not very powerful at that time, so that's why sometimes the computers can be crashed. But because of the emergence of GPU, then this one can be done easily, right? Okay, let's talk about a little bit about the milestone 2. After we talk about soft computing, how does it evolve from basic artificial neural network until the deep learning, and then we start to talk about meta heuristics and natural intelligence, right? Because this one is quite popular among students to do their research. So basically the most popular one, of course, people doing research on cuckoo search, right? Because they try to mimic the behavior of the cuckoo in finding the best optimal nest, not his, but others' bird, and then replacing his bird, his egg into that optimal one, right? So it can be related in logistic situation, right? So just a simple one. So a company that try to they call it try to place 100, for example, 100 new EV chargers in one massive area in massive city, right? So if without cuckoo search, so basically it's very difficult to find out where is the best location to place all these 100 new EV. Okay, by using cuckoo search, then they start to test random nest location that have what I call it less traffic congestion and high utilization, and then replace all those with a new one, right? But you have to remember, just finding the new location based on this, maybe it's going to getting trapped into one single places. So in cuckoo search, they call it as one method. They call it a levy flight mechanism. So this levy flight mechanism will ensure the algorithm to take very large random across the map, and by considering the what do you call it, this less traffic congestion and higher utilization, then they will locate all those 100 new EV chargers in optimal solution, in optimal places, right? Not getting crammed into one single places. Put all that 100 EV into one single places because of suggested by what do you call it, random test just now, right? So this levy flight help to find more places in bigger area. And also another example is bad algorithm. So I think this one also is quite popular. How that this bad algorithm works is mimic the echolocation in navigate in black pitch areas. So how that is work is just adjusting the frequency and loudness based on how close it to the target, right? So today it been used by smart wind turbines, right? It's just use a ping sensor in the real time, and then it adjusts the blade and in terms of pitch and angle, and then that's why they can capture the maximum kinetic energies safely, right? Based on the winds, the ping sensors immediately acts and then adjusted the blade based on where the big winds is coming, right? So it's used a bad algorithm for this. And then we look at the milestone number 3, which is overcoming the black box. I think most of you will face the same problems. You do your data mining research, and then you cannot run from the black box results, right? People will always question your results. Are you trusted your result? Because everything is black box. You don't know why that this result been presented, been processed, because everything is happen inside the box, right? So so deep learning and meta heuristics suffer from major flaw, right? Because they cannot explain why that decision been processed, right? So that's why I don't know to how to say that if you rely blindly on explainable AI, in particularly in critical fields like medicine or criminal justice or autonomous driving, so sometimes it's going to be very dangerous one, right? For example, like autonomous driving, you just 100% blindly, what do you call it, trusted this machine to base on your AI and then let the car drive by itself. I don't know, maybe I'm not trusted 100% on that, because basically you still need human touch, your common sense to drive in certain area, right? So that's why they start to introduce explainable AI, right? Why? Because they want to translate this complex mathematical model into human relation logic, right? Because basically without explainable AI, for example in bank, I mean once the application been rejected or been denied, uh, the, the 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 customer don't know why that they been rejected, right? Because there is lack of transparency. With explainable AI, so the most important thing is that they have a very what do you call it, a future importance. They're going to explain why that this application being rejected. So there's a transparency there and allow loan officers to verify their logic, right? So this is the thing that uh, people always why that most of the results we face they call it as a black box. So we need to introduce explainable AI to make our model better. So what will be the missing link in this situation? So basically, AI need human guidance. Of course, I'm also believe in that. So algorithm can process massive amount of data. Everybody knows, every data science know about this, but they lack in terms of empathy and awareness, particularly in the ethical foresight, right? And algorithms are deterministic. They are optimized, and they will do whatever things that been programmed they to do, right? But they lack in terms of lived experience, right? They cannot see long-term sociological impacts, right? And mathematically flawless AI solution can be practically morally disastrous, particularly for certain field that I mentioned just now. And human intuition is required to read the room and provide the ethical boundaries. So this is the missing link that we need to be very careful once we come out with any AI models, in AI models, right? So coming to the next slide. So basically, this is just to wrapping again. What will be the current situation, right? So in late 20 and early 21 first, the computational intelligence is transactional and directional tools, right? So human define problems, so machines blindly execute the comments. So that's what happened in the old paradigm. But in 2026 synergy, so basically AI is should work as a co-pilot. It is a bi-directional communication, right? So it is a semantic understanding. So everything need to be combinations of human insight and as well as the machine itself. So next, I just